Good afternoon. My name is Emmanuel. I am a network support engineer with F5 Support. This session, we will be taking a look at possible causes of software upgrade failures and hotfix installation failures. We will also take a brief look at the new model for Big IP software support, which has it's documented in a solution article. I just want to point out a few parts of this solution which might be relevant to you while you work with your customers in giving them advice on software installations. In this presentation, we're going to take a look at a few known defects which you should be aware of, which are relevant to software upgrades. As I mentioned earlier, we'll take a very brief look at the new release policy. We will also take a look at how the upgrade process happens for the active and standby. Well, mainly what we'll be doing here would be giving some best practice and advice. And we will take a look at an upgrade failure scenario, and finally we'll have a question and answer summary, and if there are any questions, we can address them within the context of the presentation. So let's get right to it. In preparing this presentation, I came across a few known issues prevalent in 11.x software upgrades, 11.4 to 11.6, 11.5 to 11.6, and so on. A few of them are documented here. We've got ID 488417 and 551661. In this presentation, we will be taking a look at the last two customer found defects, 468021 and 464683. These particular IDs have contributed significantly to a large number of cases open with support with regards to upgrade failures. Now, I'm going to separate this into two parts. There is the actual upgrade process which could fail, and you then have the resultant configuration loading failures. So the software upgrade itself has completed successfully. However, invoking the TMSH load syscon config command to actually load the configuration from disk to memory could fail validation errors. In this particular presentation, we will only be focusing on the actual upgrade process, the upgrade script, which does the conversion of the older configuration in your current install boot location to the new volume which you've just installed. So before we get into looking at the actual software install process, I'm just going to bring up the new model which we have, which is called the Tock release cycle. It's an alternating cycle between major releases and long-term stability releases. Now, this is documented in Solution Article 5903, the Big IP support policy. I'll bring this solution up in a moment. I'll just go over the key points here. Now, what's the tick and what's the Tock? Now, the tick starts with the X is the version number 0 and 0. So it's alternating, the ticks and the Tocks alternate between zeros and ones. When we have a major release, we would then have the X.0.0. So in this case, I can give an example of version 12, which was released recently. So version 12 actually is the starting point or the jump-off point for this new architecture. So we have 12.0.0. This will include major architectural changes, new features, and so on. Following that, we will then have the Tock, which would then, in this case, be 12.1.0. At the point in which the Tock is released, we will then enter into the maintenance mode for that particular software version. Now, what really happens if you look at the solution article is there are 2 points. When the tick is released, it would have a support cycle for standard support cycle for 15 months, and beyond that, it will reach its end of software development phase. In the event that the Tock model is released, so in this case 12.1.0, which would usually include just new features, stability improvements, and possibly hardware support, then version 12 at this point will then enter into the maintenance mode, and version 12 would then either come to its end of support date, end of software development phase, within the 15 months, that's 1 year, 3 months, or whenever 12.1.0 is released. So it's the sooner of either of these 2 conditions. So once we get to the maintenance phase with the release of the Tock, we then move to the next phase, which is the long-term stability phase. Previously, this was known as the maintenance release. Now it's called the long-term stability release. This gives you a longer period of time of support, and in which all that will be done by our product development team would be fixing customer-found defects. So in the third bullet point here, we then have the X.1.N, which is the long-term stability release. So in this case, we would then have 12.1.1, 12.1.2, 12.1.3, and so on. This is the process which F5 will be following from version 12. However, 11.5 has been included in this new model, and this is the reason why you would see 11.5.2, 11.5.3, 11.5.4, which is the current long-term stability release. I'll quickly bring up the solution here. And these highlighted portions here give you an indication of what I'm trying to explain. Version 12 is the starting point, but 11.5 has also been included. And as you can see here, because we are now currently within the maintenance mode for 11.5, we have the software development phase ending in 2019. So there is a longer period of support for 11.5.x, and it's 5 years. So it's from the first days of shipment of 11.5.2 right up to 8th of April 2019. As you can see here, we have the star for 12.0.0 because 12.1.0 is not yet released. It's still within its 15-month period. However, if 12.1.0 does get released within that time frame, then we will transition to the maintenance mode for 12.x. So once we get to the Tock stage and we then enter into the long-term stability phase, there will now be no more new features added. Only customer-found defects and stability improvements will be included. So this slide highlights the old, or what we call the legacy numbering scheme, where we had the major release, and then we had the minor release, and then we had the maintenance release. So version 10 to version 11, these were the major releases. Moving up the levels with version 11.1, 11.2, 11.3, these were the minor releases, and then we came to the maintenance releases. With the new model, we have the alternating 12.0 and then 12.1.n, which transitions to the long-term stability release. So some pieces of advice that we do have for customers is to try to get to the latest hotfix, because this would most likely contain a significant number of fixes to any customer-found defects that are out there. stability model or version is approximately what you would call a hotfix rollup. So when we get to 11.5.3, we've had some hotfixes released, such as I think hotfix 1 and 2, but there won't be a hotfix 3 because we've now had 11.5.4 released. So 11.5.4 could qualify in a way to be 11.5.3 hotfix 3. So it's best to review the release notes for each feature release and to regularly check the hotfix release notes. And I think solution 9502, which is the hotfix matrix, is also a good idea to quickly check that for any new issues that might have been identified. So in a nutshell, this is some of the key things to take away. The major release train is the X, which is the major release, architectural changes and so on, such as 10, 11, 12, 13, 14, and so on. The feature release is where we have the ticks and the talks. We move from a 0 to 1 for the minor release, and then the long-term stability releases. And then we have the maintenance release, which will be the final or the third period once the software version is released. Okay, so now we're done with taking a look at the support cycle. We'll now take a look at the software installation process. Now, this is just going to be a very brief best practice. Well, the first thing you would normally do when you are planning an upgrade would be to review the release notes for the intended software. For example, if somebody wanted to have a look at upgrading to 11.5 or 4, missed the one there. So for each software module, you could take a look at them, but I would rather go to the LTM and TMOS. And a quick scroll through upgrading from earlier versions will give you some insight into which version to move to, the install process, and a few known issues which you might need to be aware of while planning your upgrade. It also details the installation process. Installing the software, commands to use to install the software, and tasks you can do once you've completed the upgrade process, and there are embedded links within. So this is usually one of the first things to do when you're planning an upgrade, to review the release notes for the software you intend to move to. One of the reasons for including the Tock model was this second point here, in which it's advisable when you are installing a hotfix to move to the latest hotfix version on the branch of software you intend to install. There's really no point in installing the final version. It's best to just install the base image along with the latest hotfix available. This is the next point is usually, I mean, the first thing most customers are advised to do, reactivating the license prior to a software upgrade. We do have some problems which can arise with software upgrades when you haven't reactivated the license. They do not happen when you are actually installing the software. The validation of the license is not done during the actual install process. It's done when the configuration is being loaded. That's where the license check and service check is actually done, not actually during the install process. So even if you didn't reactivate the license and you then ran into a problem with the configuration loading, you could still reactivate the license at that point to resolve the problem. It's usually best practice to reactivate the license before you carry out the software upgrade. While upgrading HA pairs, it's usually best practice to start with the standby device and upgrade and do not synchronize the configuration while they're running different software versions, attempt to failover and then upgrade the new standby device which was previously active. I've recently come across a situation where a customer was upgrading a VCMP guest and accidentally forced the standby device offline. Forcing the device offline is one of the options customers usually take in some cases to prevent active situations and any conflicts. So the customer went ahead to force the guest offline, and he then lost access to the device because the self-IP addresses were no longer reachable, and the HA, for example, failover wouldn't work in that case because the self-IP addresses are needed. So if you are working with an appliance and you force the device offline, yes, the management IP address you can still access the management IP address regardless of whether it's a VCMP guest or an appliance. The self-IP addresses is where you would then have to be careful. If it's on an appliance, connections to the self-IP addresses are still maintained, so your HA over the self-IP addresses would still function. However, if it's on a VPRION system, the connections will be terminated. So there is a separate process to reset the device trust, for example, and force the device offline in that scenario. It's documented in a solution article. And once you have the base image in the shared images directory, and you have the hotfix also in the directory, you can proceed with your hotfix installation by installing the hotfix directly. The install script will first search for the base image, install that, and then install the hotfix on top of it. Now, in my experience and with some of my colleagues, we've seen that most of the upgrade failures can happen with failure to reactivate the license, which I explained earlier doesn't actually impact on the actual upgrade itself. It's the configuration loading, because that's where the validation is done. Insufficient volume space on disk, and the heuristics in the QK views usually pick up on this because they would usually give you a reference to solution 10636, which has some links within it, which in most cases give you specific information on what the actual problem is with the disk space. And for the purposes of this presentation, we'll be taking a look at the third bullet point there, which is the script validation and the UCS failure. The next scenario, which ties in with the reactivation of the licenses, the configuration failing to load post-upgrade, but we won't really delve much into that in this presentation. Now, for the upgrade path, you would either go from version 9 to version 10, version 10 to version 11, version 10 to version 12, or version 11 to version 12, as the case may be. In the past, where we had a lot of customers moving across version 10 to version 11, there were lots of configuration problems, especially with the conversion of the version 10 configuration into the version 11 configuration, a lot of inconsistencies. So diagnosing problems like this, we would usually use the big pipe DAO script. I think a lot of partners are actually familiar with this. This helps you to validate what exactly in the configuration is causing, or particular object in the configuration is causing it to fail to load. And there is a counterpart command for the GTM configuration. In the version 10, you had several files: the region file, the big IP GTM configuration had a separate file, and then the topology had a separate file. These files were all merged into the big IP underscore GTM.conf file in GTM. So the conversion or merging of these individual files in version 10 to version into the GTM.conf file in version 11 could fail. And the reverse of the GTM pass command, the srap mtg is actually the reverse of GTM pass, would help to validate errors or configuration objects in the version 10 configuration, and then temporarily convert them into the version 11. You would then save this configuration using the sysconfig GTM only, or save sysconfig for the rest of the configuration. The dial here is also the reverse of the load command spelled backwards. Now, I'm going to bring up two devices which we'll use to review the current scenario. They are HA pair. I'll just bring them up side by side first of all. These are HA pair running version 11.x 11.4.1 final, no hotfix, which goes against everything I've actually preached. And we have the following available images. There's the base image for 11.4.1, 11.5.3, and we have 11.5.4 base image, 11.5.0, and 11.6. Now, on the standby device, an installation was attempted to install version 11.5.0. Now, this installation happened to fail. And the reason for it failing was an unknown cause. The UCS application failed. This was an upgrade. We're currently booted in 11.4.1. We were attempting to install 11.5.0. Now, the reason for the failure, which we'll see in a bit, was due to one of the known issues which was identified earlier in the presentation. Now, the first thing we're going to do here is identify, look at the configuration. It's a very small configuration. Now, what was done here was a client SSL profile was created, the highlighted portion here, and it defaults from the client SSL insecure compatible profile. This is the profile in question. This was created just for the test. It defaults from the client insecure compatible. I'm just going to run a very quick command here. I'll come back to this later. Now, we've got, I'll quickly bring up my two 4.48.8. So looking at the profiles we have the client SSL profile, the client SSL insecure compatible, and the warm default client SSL profile. These are default profiles. So creating a child profile would either inherit from one of these three. In this case, this profile inherits from one of these three default profiles. Now, if you were to select the client SSL profile, all good and fine. If you selected from the warm default client SSL profile or client SSL insecure compatible profile, you would then run into the problem which caused this software installation to fail. And to further troubleshoot this, you first of all have a look at the output of the TMSH showsys software, and then you would inspect the live install log. So once this software process is initiated, we have the RPM files for the directory structures. So far, so good. The installation process is going on fine. And then we come to the point where the configuration is installed, which is the UCS file, starting at this point. So the UCS is extracted. A version check is done, 11.4.1, and the system is installing it on is 11.5.0. It validates the host name. It commences the installation. It attempts to install the configuration. And then we come to this part, out of memory. And after a period of time, live install log then logs the software failure and gives a return code. For brevity, I've just included a part of the output we've seen from the TMSH showsys software command and the live install command output. So the reason why this failed is what's documented. I'm going to take you a couple of steps back. Installing the UCS archive causes the IM to consume memory and the upgrade fails, and then it has a related ID. UCS install from older version fails if the client SSL profile is inherited from either client SSL insecure or the client SSL warm. So what actually happens here is at the point in which the UCS is being installed, unfortunately on the 1150 installation script, there is some missing dependencies with the client SSL insecure compatible and the warm client SSL profile. So you then, the IM installer, that's the image manager, then gets into a loop of trying to pass a variable that doesn't exist. And this causes the IM process to eventually run out of memory, and that stalls the installation of the UCS at this point during the upgrade process. So it's not particularly peculiar to the install process alone. Loading the UCS with those profiles would also make you run into the same problem. So this is documented in a solution link. I'm going to bring that up now. So it's documented in this solution article, this behavior. And so in this case, the software installation actually stalls and fails, and it's nearly impossible for you to continue the upgrade process. Now, the workaround for this particular issue is to go back to the the earlier software version. In this case, it's the 1140, and you can then reorder the dependency of the client SSL profile you've created. In a previous case, which I have personally worked, the customer just had a few of these client SSL profiles, so it was relatively straightforward for him to go back and make the child profile default from the client SSL profile and not from the client SSL insecure compatible profile. But for a customer who has got a very large configuration with lots of virtual servers inheriting these profiles, that could be cumbersome. Now, the key points to take away from the analysis we did on the command line is the UCS configuration is created, and then the installation commences on the new volume. At some point where the UCS is invoked to install the configuration to the 1150 volume, it gets stuck because there's a variable which is being a non-existent variable, which is the SSL profiles in question. The client SSL profile is there. It's just the client SSL and warm SSL profiles which are not in that version, and this gets the IM into an infinite loop, and eventually the kernel OM is invoked to kill off the process. So this is described here. The upgrade failure occurs because of these profiles. They're not properly defined in the upgrade conversion script, which is supposed to convert the 1140 configuration into the 1150. So we're referencing objects that don't exist, and this is what gets it into a loop until it runs out of memory. and I also have that documented in 15974. So this is more relevant to my specific scenario with 11 upgrades from 11.4.1 to 11.5, and this is the ID. Now, in the meantime, I'm going to quickly spin up. This is the active device. We also have the relevant base images as well, 11.5.4. We have the same configuration. We have the same test profile defaulting from the client SSL profile. And we'll attempt an installation here while we continue with the presentation and see if this. So we'll come back to this and check on the progress if it fails. So the troubleshooting steps which we had a look at while investigating the upgrade failure were to review the output of the TMSH software command. This gave us an indication that the upgrade had failed, and the live install daemon tracks the installation of software. So this will be the very first place to look and to page through the logs to see at what point it fails and if there are any clues or pointers we can take a look at. Now, the live install started at a certain timestamp. We then look at where it failed and possibly a return code and a reason for the failure might be logged. In this case, a further review of the kernel logs for the out of memory gave us a pointer that the process had, the IM process had run out of memory and had caused it to fail. And then using the ASCII5 knowledge base, we then did a little bit of digging to see if there was any existing known issues that might explain what's going on. So I'll just quickly get back to the installation if it's completed. And it has completed without failing. So this, in many ways, highlights why it's usually best to go to the latest hotfix or version available, because it's most likely that some of these issues, in this case in 11.50 and 11.51, have already been fixed. Now, this was fixed in 11.52, a long-term stability release in 11.52, and 11.54 is a hotfix roll-up of 11.52 and 11.53 and fixes from earlier versions. So now, because the client SSL insecure compatible profile is properly defined in the 11.5.x install script, we no longer have this problem with the installation. So this is completed successfully. So I've just documented some of the user solution articles tracking software upgrades, possible reasons why they fail, and some best practices for carrying out software upgrades or installation of hotfixes. The solution I referenced earlier, 10636, relates to problems that can arise with insufficient disk space. We also have an interesting solution here on how you can control the import of the configuration if you want to do an installation but do not want to move or roll forward the configuration automatically, which is what actually happens when you install to a new slot. You can control that with the copy config command 1476724, and also making use of the live installed database keys. So to recap what we've covered in this presentation, we took a look at the software upgrade failures and how they can happen. In this case, we looked at validation errors from the installation script. We also briefly touched on the Tock model, and we did some very brief debugging, investigating the live install logs to identify why the solution of upgrade or hotfix installation could have failed. So at this point, if there are questions on the presentation, we can take them.